Hello everyone. So in this video lecture I will explain you pre-emptive priority scheduling. Okay, so I hope you have watched my previous video related to non-pre-emptive priority scheduling. If you haven't, then must watch, and then only you can understand difference between pre-emptive and non-pre-emptive. Okay, so this concept will be clear to you if you have watched first non-pre-emptive priority scheduling algorithm. Okay, so let's start. Selection criteria in this algorithm is the process that has highest priority, it will be solved first, and the decision mode is pre-emptive. Okay, now there is a difference. In non-pre-emptive, decision mode is based on pre-emptive nature, whereas in pre-emptive priority scheduling, decision is pre-emptive nature. Okay, so what does it mean pre-emptive? When a new process arrives, its priority is compared with the current process priority. Okay, and if the new process has higher priority than the current one, then the current process is suspended and new job is started. Why? Because it is our policy that is higher priority process gets scheduled. So now the difference between this non-pre-emptive and pre-emptive priority scheduling is that over here when new process arrive and it has higher priority compared to current running process priority, then current will be suspended, it is suspended, and the new arrival process with higher priority will get CPU for execution. Okay, this strategy can be implemented by using the sorted FIFO queue, but this queue are sorted based on the priority with highest priority process at the front end. When CPU becomes free, process from the first position in the queue is selected to run. Okay, let's see one example. So just like in the non-pre-emptive scheduling algorithm, you also get information like process, it's with their arrival time, burst time, and its priority. Okay, now there is one important point that you cannot assume just like that. Okay, if this information is not given, that means this particular priority numbers, how it will be treated, that means smaller numbers, that means higher priority or not. So if it is not given, then you have to assume, write it down, and then only you should calculate. Okay, but majority of the time it is mentioned in your numerical definition, so don't worry about that. So over here priority is also mentioned, and the small values for priority means higher priority of the process. It is also possible that largest value for priority means higher priority of the process. Okay, it depends on numerical, if it is mentioned, what is mentioned in that. So as arrival time of the process is given, so at let's say right now time t is equals to 0 and process p0 has arrived. Okay, so obviously we have no another process to execute, not to compare anything. Okay, so process p0 will be executed. So just process p0 has executed till t is equals to 1. Okay, t is equals to 1, and at this time this new process has arrived, that is process p1. Okay, you can see arrival of new process is affecting the Gantt chart. Okay, that means it is pre-emptive nature. Okay, so process p1 arrives at a time t is equals to 1 with 6 burst time and with priority 4. Now just compare, what is priority of p0, that is 5. What is priority of p1, that is 4. That means new arriving process, that is p1, has higher priority process. Okay, that is this is your queue. So in the queue you have two processes, p0 and p1. Okay, but p1 is 4 and it is 5, that means p1 has higher priority compared to p0. That's why process switching will occur, and from now onwards p1 will be executed. Okay, so p1 will be executed till time 3. Why it has stopped? Because at time t is equals to 3, new process p2 has arrived. Okay, new process p2 has arrived, and you can, so now total you have 3 processes, P0, P2 and P1. Okay. Now P1 that has priority of 4, P2 which has priority 2 and P0 is of lowest priority. So from this priorities you can see, oh, P2 which has just arriving process, it has the highest priority among all the processes. So again context which will occur, okay, and process P2 will be executed. And how much time it required to complete its execution? 2 units. So from 3 to 4, 4 to 5. Okay, so till now this process is executed and it just required 2 units and it has completed now. Okay, so P2 is finished now. So now you have these 3 processes, P0, P1 and P3. Okay, so among these processes 0, 4 and 5, you have process P3 which arrived at unit 5, Now it is just coincident in this numerical that process P2 is also completed and the process P3 also arrived at this 5 unit. Okay, if this process is not completed yet, then you have to consider it in the queue. Okay, it is not finished if it was the case, but process P2 has completed, that's why it is not in the queue. So now process P3, it has priority number 0 and the smallest value represent higher priority. That means process P3 will be executed. Okay, so again context switches occur. Okay, so process P3 require 4 unit. So from 5 to 9 process P3 will be executed, and after that you can see now that is no new process arrival. Okay, so in the queue you have process P0 and P1. So between these two process P1, it is of higher priority. Why? Because its number is small compared to 5. That is the only reason. So P1 will be executed, and now you just need to take care over here how many units are executed. P1 2 unit, 1 to 2, 2 to 3. Okay, so 2 unit has been executed of P1, and how much it required total? That is 6. So 6 minus 2, so that means 4 units are still remaining of process P1. So over here you can see it is just a remaining 4 units. Okay, 9 to 10, 11, 12. So total 4 bus time. Okay, that is the remaining. It just resume its execution. Okay, it has executed its 2 instruction and the remaining 4 are over here. Okay, so don't be confused over here. Why ma'am, why it is not 6, it is just only 4. Okay, because 2 is already spent here. Okay, so process P1 is completed. Now it comes process P0. Okay, and how much it required process P0? 10, but initial 1 unit of CPU bus time it has already executed. Okay, that's why it is just 13 to 22. That means total 9 unit. Okay, because 1 unit is already executed at the starting. So that is the Gantt chart of the preemptive priority scheduling. Now if you want to see clearly difference between Gantt chart, then just see in the video lecture of a non-preemptive priority scheduling and just see the difference between this chart and that chart. Okay, you can clearly see the difference, how many context switching are occurring in this example and in that. Numerical definition is the same in both the video lecture. Okay, so you can compare directly. Now this calculation, it is very easy if you have draw this chart without any mistake. Okay, so finish time of all the process you can get using this chart. After that, turnaround time T1 minus T0. Okay, simple, just use this formula and calculate. So at the end of the at the end you will get average turnaround time, that is 10 millisecond, average waiting time, that is 4.5 millisecond. Now advantage of is priority is considered so critical process can get even better response time. Okay, if there are certain situations and some process needs to be executed immediately, and if priority scheduling is implemented, then this process will get immediate response, okay, and it will get it will not wait for a long time, okay. Disadvantage: starvation is possible for a low priority process, and it can be overcome by using the technique called aging. And in this process, gradually increase the priority of the processes that wait in the system for a long time. Now, context switch overhead is there, even compared to non-preemptive priority scheduling algorithm also. Okay, so that's all about preemptive priority scheduling. Okay, so thanks for watching. Keep practicing. Have a nice day.